we express that as this sum. Okay? It's well known and easily proven that, and I'll just tell you how it's easily proven so you can see that it's easy. You have to work out the details, and we're not going to do that. Okay, that's 1, right? Okay? Then 1/2 plus 1/3 plus 1/4 plus 1/5 is at least 1. Okay? So this is 1, the next 4 terms are 1, the next 8 terms add up to at least 1, the next 16 terms add up to at least 1. Not hard to prove it. Okay? And there's no end to it, so you get as many 1s as you like. The further you go, the more 1s you get, right? So this approaches infinity, okay? It's not a finite sum. So, the area is undefined. The integral from 0 to 1 of 1 over x dx is said to diverge. Okay? Now, if these numbers were 1, 1 over 2 squared, 1 over 3 squared, 1 over n squared, and so forth, it would never approach infinity. It would converge to some value that we could calculate. Okay? But this diverges. So converges means that when you do this sum, it's finite. Always finite and never exceeds some certain limit. And that limit is your integral. Okay? So, for example, in the second one, the series was 1 over x squared, I think, wasn't it?
Yeah.
Well, if you did 1 over x squared, that's exactly what you would get. You know, what do you get when you square 1 over n? You get 1 over n squared, right? Multiply that by n, okay? And you get 1 over n. But then the next one, well, you do all the calculations, and you see that what you would have here, you would have n over 2, except it wouldn't be n over 2 now. You'd be squaring this. It would be n over 4, right? Which is n over 2 squared. You'd have n over 3 squared and so forth. So just what I said, easy to prove that that converges, okay? I'm sorry. No, that should diverge. No, okay, I need to write it out. Okay? You get 4 over n, 9 over n, etc. Be 1 over n times sum of the squares. Okay, whatever I'm doing in my head isn't right, but the idea still persists, okay? Well, what we can do with this integral is, and I'm getting way over time here. That was ignorant.